It is Douglas Starnes that will be presenting, and he will be discussing AI for everyone with Azure AI Services. Douglas joins us from the Memphis, Tennessee area. He is a technology entrepreneur, content creator, and five-time Microsoft MVP in developer technologies and AI. He's also the organizer of various conferences, speaker at various user groups, and he's spoken before at the Azure Cleveland User Group, and we're glad to have him with us again. So with that, the floor is yours, Doug. Excuse me. The floor is yours, Douglas.
All right, thanks, Sam. Thanks for having me. Thanks everybody for sticking around. I even though Sam said I could go over, I won't. Don't want to keep people on. Don't want to keep people on a Friday afternoon, especially since we have people here from time zones that are later than mine. But go ahead and get started here. So this is AI for everyone with Azure AI Services. What was I think it was Jared who said that his talk was not necessarily going to go into implementation of AI, and this one won't either. This one is more of a practitioner perspective, but this has very very wide reach, and I think you'll see why as we go through it. First of all, okay, that's not good. There we go. Let's go ahead and the obligatory narcissism slide, or about me. So again, I'm Douglas. Sam went over some of this, so I'll go through it rather quickly. But in the Memphis area, actually in Oakland, to the east of Fayette County, to the east of Shelby County, where Memphis is located. I'm a professional explainer. This is what I do. So I do work for Pluralsight. I've done some work for other for a couple of other companies as well in the past. I run the Memphis Python User Group here. It's the third Monday of the month. Anybody interested in speaking at the Memphis Python User Group, please do contact me. I'll have my link tree up here in a minute. As I like to say, our plea for speakers is continuously open. Obviously, I'm a speaker. I do a lot of this, and again, the five-time, hopefully in a few months be six. Five-time most valuable professional for developer technologies in Python and the AI platform with Azure AI Services. Here's my link tree. What you'll find on there is you'll find my LinkedIn, which is the best way to get in touch with me. Also, my blog, which I'm going to restart soon, but there's still a lot of good content up there related to some of the stuff we're going to talk about today. And then also my YouTube channel, which is where I'm really working on getting traction right now. And there's also content relevant to what we're talking about today. What was earlier in the day? I think it was Jeffrey talking about Olama. If you liked Olama, go on there. I've got about an hour-long playlist about Olama on there. It's all Python related, although I'm probably going to do some .NET and JavaScript later. Okay, if you've enjoyed this event, there's actually another one coming up in 2 weeks. That's going to be the one I'm running here for Memphis. It will be virtual as well. It's going to be on Friday, April 25th. That is again 2 weeks from today. Here is the link. Let me see. I don't know if I can put that link in. I don't know if I can copy that link into the chat. Well, at any rate, we'll get it out to you somehow. But that's the link. It'll start. So everything will be Central Time. So it'll start. I'm planning on starting it at 9 a.m. Central Time. And then actually my CFP is actually still open. I believe it's through midnight tonight. But it is open through the rest of the day, and there is the link for that as well. So if I get several more speakers, I can actually accept everybody and do 2 tracks, which I'd really like to be able to do. Okay, but moving on, let's get to the content. So AI is hard. That's why we're here today, because AI is hard, like really hard. Okay, we are trying to mimic the output of human beings, and we do not understand the human brain well enough to do that, to be totally honest with you. I think it's probably been said more than one time today that you're going to find that artificial intelligence is very artificial and not that intelligent. So that's another thing that makes it really, really hard. Somebody once put it to me, so it's kind of like educated guessing. Well, in some ways, yes, but it's educated guessing that's been refined over and over and over and over and over again, and that's why it's so hard. So let's take a look at at implementing this. Why does it take to implement this AI that's so hard? Well, first of all, LLMs are all the rage right now. This is here I'm talking about Llama 3.2. Llama 4, I believe, was released last week, but Llama 3.2 from Meta. And we're talking about here is the 3 billion parameter model. And this is actually a small model. 3 billion, that's a large number. But it's actually a small model when you consider that there's also what I think Llama 3.1, don't quote me on that, but one of the Llama versions has a 405 billion parameter model. DeepSeek is almost 700 billion parameters. Nobody knows quite for sure how many parameters GPT-4o is, but it's been rumored that it's up to 1 trillion parameters. So this is actually a small model. To train this, Meta used what at the time, I believe the cutoff date is like mid-2023, so almost 2 years ago, the NVIDIA H100, which is state of the art at the time. It's still a good GPU, although they've progressed some since then. I mean, these things are powerhouses. I mean, the thing's got 80 gigabytes of memory with a bandwidth of 3.5 terabytes. That's crazy, ridiculously fast. But still, and there's a picture of the guts of one, but still it took 460,000 GPU hours. So in other words, if you just had one of these super powerful GPUs, it would take 460,000 hours to train this small language model. 460,000 hours is on the order of about 52.5 years. So Meta said, well, we don't want training this small model to be a once in a lifetime opportunity. So what do? We scale up. So if you had 1,000 of these, it would take about three weeks. I think 19.5 days is where it comes in. Now, if you want to look at this in even larger scale, in Southwest Memphis, near where I live, there used to be an appliance, I think it was an assembly facility, a company called Electrolux. Well, they during the shutdowns, they closed it down. And last year, Elon Musk and XAI bought it, and they put 100,000 of these H100s in there, and they're using it to train Grok, which is of course the AI assistant for that X has. But still, even with all this, it's not enough. You don't just get 1 or 1,000 or 100,000 of these super powerful GPUs and boom, you've got an LLM. You have to have people who understand neural networks. They have to understand how to train this thing. And these are people who, have advanced degrees. They're geekier and nerdier than I am in some cases. It's scary to think that such people exist, but they do. And they have to know about the other things, such as PyTorch. This is a Python package for, actually it's a kind of a layer on top of Torch, which is written in C++. But at any rate, this is what you use to code everything. You have to know about math. Lots and lots of math. If you are math phobic, do not look under the hood of a neural network. And still, there's even more. You have to have the infrastructure to run all of these GPUs. Okay, cooling. These things put out a lot of heat. What was that? I think it was Jeffrey earlier today was showing you the stats on his system and showing you, how just even a small language model could make a GPU. Can make GPU usage spike. Backup, networking, security. Okay, this is something people don't think about sometimes. I mean, I can't just go down to the XAI data center in Southwest Memphis and say, "Hey, I'd like to see Grok's brain." Anybody who is a fan of the original Star Trek series, look at season 3, episode 1, and you'll get that reference. But at any rate, power. This is a big one. These things consume 700 watts each. If we've got 1,000 of them, that's 700 kilowatts of power that we're consuming. So there's a lot that goes into this, and we're not done yet. There's an even bigger blocking factor. Last time I looked, which is in the past month, I believe, maybe a little bit longer, the current market price for an H100, it's about $30,000 each. In addition, these people with advanced degrees, they don't work for minimum wage. And if you go to your local utility company and ask them for 700 kilowatts of power for 3 weeks, they're going to expect something in return. Now, the problem with this is that users expect AI features now. Even the users who don't want AI, the users who don't trust AI, they still expect it. And that creates a quandary. So over here on one side, you've got the AI hungry users, and over here, you've got what it takes to feed the AI hungry users. And bridging the gap, stuck in the middle, is you. So fortunately, there is a solution to how to bridge this gap, and that is why Azure AI Services exists. So let's see how Azure AI Services helps with this problem. So first of all, the Azure AI Services, these are machine learning models because machine learning is a branch of artificial intelligence. They are trained at Microsoft scale. So Microsoft scale, Meta scale, Google scale, Amazon scale. There are very few companies that can do this. So we're talking about these are the ones again that can take weeks to train, targeting common AI scenarios. So these are things like sentiment analysis, object detection, text to speech, and such. So you don't need those really, really powerful GPUs at 30 grand each. They are exposed as REST APIs. So in other words, all you have to be able, you don't have to deal with any of the infrastructure. All you have to be able to do is call a REST API. It's another one that we don't have to worry about. You actually don't have to know anything about AI. If you can make a call to a REST API or use the SDK, you can add AI features to almost any application using almost any language. So we don't need these folks anymore, but we do appreciate their efforts in training the models. And serverless billing. You can use this serverlessly. So that means, literally you pay for only what you use. Now you can get provisioned instances as well, and there's some other ways to run it, but serverless, but you don't have to start off putting forth hundreds or thousands of dollars. You can actually, and some of them, if you're on the free tiers, you can experiment with them for free. And but at any rate, we're talking like pennies per transaction or even less in some cases. So our cost is not. I'm hearing so. Hang on, excuse me, just 1 second. I think I just turned on a TV accidentally with my voice. Hang on, just a second. Excuse me, when I said the name of that of AMAZON, it turned on a Fire TV. Okay, great. So at any rate, one of the hazards of hazards of live streaming. But at any rate, so this is how Azure AI Services is going to get rid of some of those problems for us. Now, how do you access these? Well, there's 4 ways that you can access these, and now my mouse is messed up again. Come on. There we go. So the first one is a Docker container. I'm not going to talk a lot about this one because it's not really that exciting, but this is really good for if you have data that you want to keep on-prem. So you've got sensitive data, private data, and you don't want to put that up into the public cloud, which would be something like Azure. The only connection to Azure is for usage stats for billing purposes. So you're going to run everything in your data center in a Docker container, and the only thing that's going to go to Azure is how much you use it. Now, another way, and this is probably one of the more popular ways, is an SDK. And SDKs exist for popular languages, so Python, C#, Java, JavaScript, and TypeScript. And these allow you to work with language native objects. So as we all know, REST APIs generally speak JSON. Instead, we're going to be work with a Python object or a C# object. And allow us to, and we won't have to parse all the JSON. Also, we won't have to mess with things like refreshing tokens or fiddling with HTTP requests. We don't have to do that. In fact, most of the time, it reduces the hard work of making that prediction, the machine learning magic, if you will. It reduces it to a single line of code in many cases. Everything that comes before that's going to be boilerplate configurations, such as authorizing and creating a client, and everything after that is going to be parsing the results, which is what makes your application unique. So that's where you want to spend all of your time, but you don't want to spend all of your time again with all that all that stuff that you have to pipe up yourself. There's also the REST API. Again, this one you can use any HTTP client. So you could use requests with Python. I forget what the one for C# is. You use Axios. with JavaScript, or you could use Go, you could use Swift, you could use Kotlin. If Haskell supports, making HTTP requests, you can call Azure AI Services in a Haskell application. It is the most flexible because it is the definitive reference. The SDK does not support all of the features of the REST API, and the Docker container does not support all of the services in the AI services collection. But the REST API, it's got everything. Let's see here. Then there's also these web-based studios, and there are I think there's about a half dozen services that support these. These are obviously web-based. They're going to be a UI of some sort, and this allows you to explore and experiment with the features. So kind of try before you buy. Although using this, you will be billed or eat a free quota if you got one. So it's not just completely free. And also there are certain tasks like training custom models. I used it to generate some of the assets for some of the later demos, but we'll see examples of these last three. Like I said, the Docker container is not really that exciting. It's more of a administrative task. Okay, this is not the complete list of the services that are available. I'm not going to go through every single one of these in detail. Some of them have, like Azure OpenAI, there's already been talk of that today. Search has already been talked about, but I'm going to go through some of them just so you get an overview of the breadth of what you can do with this, because I always tell people, they say, hey, I need an app and I need this AI feature. Well, Azure AI Services should be your first line of defense, because it'll probably take care of 90% of what you need. So you don't have to train a model or really even know anything about AI in many cases. But so OpenAI, like I said, I'm not really going to go into this one in detail. Basically, ChatGPT, all the things. It's got all the different models. If you're using this within Azure, you do get the Azure features. You get security with Entra ID, monitoring, unified billing. Prompt flow is something that is not available in the that's not available just from OpenAI. But like I said, we've talked about that today before. Content safety, another one that I'm going to just kind of gloss over. For one reason is because demoing it would probably violate the code of conduct, but this is for filtering out potentially inappropriate content. Also, this one right here is interesting. Prompt shields. What it'll do is it'll analyze your prompts, the prompts that are coming into an LLM, to make sure that they won't do what's called jailbreaking it or force it to generate harmful content. Document intelligence. This is one that's hot right now. This is one of the hottest services that they've got going on. It used to be called Form Recognizer. And you'd be surprised how much data and information is actually still stored in forms, both physical and virtual, typed and handwritten. And right now, that's a manual process, or traditionally has been a manual process. But now with document intelligence, is going to be, you can automate this process. So you can extract information from forms, documents, and such. And you might be thinking, well, hey, that's just OCR. It's been around for a long time. This is actually more than OCR. These are models that have been focused on different types of documents. So they are context aware. So they'll recognize different structures like tables and options and checkboxes and other layouts. Some of those layouts they have for checks or invoices, tax documents, and there are others. And you can also train your own models. That's the really cool thing about the Azure AI services. Even though they are pre-trained models, there are ways that you can extend them, some of them with your own data. Okay, let's talk about the face service. This one, the only reason I really labor over this one is because there's a lot of confusion sometimes about these three terms: facial detection, recognition, and analysis. Some people use these interchangeably, and there are actually differences between them. So facial detection does pretty much what it says. It identifies 0 or more objects representing faces. So it's a binary classifier. Is there a face in this picture or not? Hot dog or not hot dog. Facial recognition actually works on top of facial identification, and it will associate or attempt to associate an identity with a detected face. Further, facial analysis. This looks at the location of facial landmarks, so facial features such as eyes, nose, mouth, and also different attributes. So, is this person wearing a hat? Do they have glasses, jewelry, and that kind of thing? Now, the other reason why I bring this up is because facial detection, you can use it as much as you can pay for it. But if you want to use, facial detection, you can use as much as you can pay for. Facial recognition and facial analysis, because of privacy concerns, you have to make your case to Microsoft. These are gated, and Microsoft will have to grant you access. All right, language. This is one of the more capable services, and they actually had some when they did the rebranding about a year and a half ago. They rolled several services into the language service, so this one's going to have quite a few in it. But sentiment analysis. This is kind of the low-hanging fruit. I also say that the language service is one of the easier services to use. But sentiment analysis. This is kind of the hello world in some ways of AI services. You throw in a body of text. Does it have positive, negative, or neutral sentiment? Summarization. Give me the Cliff Notes version of this particular body of text. Key phrase extraction. What are the major ideas, the important points, the talking points, if you will? Named entity recognition. Notable and or famous people, places, and things. Question answering. Okay, throw me a body of text. I will throw it a body of text. It will formulate questions that can be used to reinforce understanding. Conversational language understanding. This comes down to forming a series of intents in order to use some kind of a conversational agent. And PII, personally identifiable information, such as social security numbers. Hey, you probably shouldn't put that in there. So to detect that information and root it out. Search. I'm not really going to go that deep into search. Basically, the main thing that for purposes today that it's used for is this vector search engine that's used with RAG, retrieval augmented generation. But that's all I'm going to say about that one for now. Speech. This is probably my favorite one. My demos are definitely more in depth with this one, but I really, really like the speech service, and there's a lot that you can do with it as well. So first, speech recognition, speech to text. I talk to the service. It gives me a text transcript back. And then also the inverse of that, which is speech synthesis. So you give it the transcript or a body of text, and it will generate a audio representation of it. Translation. Talk to it in one language. It'll talk back or it will repeat what you said in another language. Speaker identification, also called speaker diarization. I'm going to have a demo of this here in a minute, but this is if you have a recording of a meeting or a conversation that has multiple people, it will distinguish the speakers. It will distinguish the different speakers and attribute what they said to each speaker. Custom neural voices. You can record samples of yourself or somebody else with their permission, and the speech service will train a model that will replicate closely their voice. This is another one that in certain cases is gated. You have to, I forget exactly what it is that you have to do, but you have to tell Microsoft, hey, I've got this person's permission and I accept responsibility and everything, because again, they're worried about abuse with this one. And avatars, a talking head. You literally can have a little video of somebody of a person that looks, and you can also train custom avatars now. You can put gestures. You can have gestures in, so you can, and then also SSML, speech synthesis markup language. So if you have unique pronunciations or you want to put pauses in a specific place, you can do that with the speech service. Translator. I'm going to kind of gloss over this one as well. How am I doing on time? I've gone 25 minutes already. Dang. But translator, pretty much, what it says, it'll translate text between languages. You can filter out obscene words. Language detection, what language is this? And then also this one is another one that you can train custom models. One of the caveats here, though, is that one of the languages must be English. So you can go English to German, you can go German to English, you can't go German to French. And finally, wrapping up is the vision service. So this one is pretty obvious. You extract information from images of some kind. OCR. Now we already talked about OCR with the document intelligence. This is a more generalized OCR model, and I've got a demo of it that'll show this. But This is for things, if you want like reading signs or just any random printed text. It doesn't have to be in a strict format like the document intelligence service expects. Object detection, again, not just necessarily is there a face in this image, but what objects are there in this image, hot dogs and otherwise. Image tagging, so generate keywords. Image captioning, again, kind of like the key phrase extraction, except with images. Background removal. This is a big one. This is one that people like to do in batch a lot. And also thumbnail generation. Cropping a thumbnail, generally what you want to do is you want to remove all of the noise and focus in on the important subject. Vision Service can help you do that. You can train custom models. Again, this is used often for product defects and that kind of looking for product defects. And then also there you have to have large amounts of image files for these, and you have to label all of them. You can actually train a model in using the Vision Service, train a model to automatically label your images. So you can train AI to train an AI model. Okay, with that, let's take a look, spend the rest of the time doing some demos. Let me see how much trouble I can cause here. In case you did not notice, I am obsessed with Nashville. But let's get first. Oh, I thought I had this already. I thought I had this up already. Oh, okay, no big deal. I can still do this. Won't take long to look for this. Come on. All right, here we go. So this one will work. So when you create an instance, when you provision an instance of a resource, you will get over here in the keys and endpoint, you will get two keys. There'll be a location and an endpoint. Location's not always necessarily used, but these keys always are, and they are masked, so you might assume that they are like passwords. So basically what will happen is if you're using the REST API, you'll pass these in as headers. If you're using the SDK, you will these will be passed to the client of some sort. Now notice that there's two of them. And the nice thing about this is if one of them is compromised or you're using good security practice and you're rotating them out, what you can do is you can switch to one while regenerating the other, and then you don't have any downtime. So that's pretty much that's going to be pretty much constant across all of them. Now, in the case of the document intelligence service, and there are also some others that we can look at. You'll have this button down here to go to a studio, to one of those web-based studios, and in this case, we have the Document Intelligence Studio. So I'll click on that, and I'll get this dashboard of all of the different features. Now, not all of the features are covered. But what we can do here is we can take a look at some of these pre-built models. So for example, let's take a look at an invoice. And I'll sign in. And again, where is it? Oh, I don't see it on here, on this one. Oh, well, it's on the others. I know that. Anyway, there's a little checkbox generally saying, hey, I understand that using this, I may be billed for that. I could be billed or my quota will be eaten up or whatever. So there's some examples here, but I have some, but just to prove that I have nothing up my sleeve, I'm going to bring in a different one. So here's a PDF. Here, actually, I'll show you I guess I should show you the PDF first. So here is a PDF of an invoice. This is just a template that I PDF from Canva. They have lots of different, but yeah, and the thing is, the invoices, yes, there are parts of this that are kind of consistent across invoices. You're going to have the name of, you're going to have an invoice ID, you'll have a date, you'll have like a bill of line items, total, maybe terms or something. This one does have terms on it, something like that. But so this particular pre-built model is meant to look for those. So if I drag this over here, it's going to show it to me here. If I say run analysis, and you can also use images. There are different types. There are different document types. You'll see that it's highlighting over here what it found. So if I can zoom in for just a little bit here, whoops, drag this down. You'll see here this one. This is the customer name and address. It found the invoice date, found the invoice ID. Remember I said that it will recognize structures. This here is a table. It says it's got a table with 9 rows and 5 columns, which is true if you include the headers as the first row, and then each row here, you see the items in each row. And notice it's giving me a confidence score as well. Then down here is total, subtotal. This is saying it's a customer ID. It's actually an account number on this one, but at any rate, you can see that it did pull those things out. Now you can also go over here in the studio and you can look at some of the different structures. So here it found these tables. This is the JSON that you would have to parse if you were using the raw REST API. But you can see it's very, very detailed. So for each particular piece of content that it finds, it gives you the bounds of it, and then again the confidence score as well, and even sample code that you could use. All you need to do is plug your endpoint and key in here, and you could run this. Gives you samples in Python, JavaScript, and C#. So that's all I'm going to talk about with the document intelligence service, because when you start doing, because when you start writing code or start writing an application against it, and start just digging down into that result, it becomes pretty repetitive sometimes. But there are other things that you can do. You can specify, which fields you want to look for. Lots and lots of different stuff. There is a if you have an Azure account, and I believe this is free forever. I believe you get 500. You can analyze 500 pages per month for free. You can do it for at least 12 months, but it may be forever. So you can play with this. Yourself. Okay, let's take a look now at. Let's do Speech Studio. Let's see here. Let me get back to. Let me see here. This is the one I want, isn't it? Here, I think it'll work for what I want. Okay, so if I go to the Speech Studio here, and I want to make sure, yes, I'm right. Okay, then you'll see several different things that I can do with this. So, for example, here's where you can do all your speech to text. You can do I want text to speech is actually what I want. I think Matt was talking about some of the different voices that it has. Let's see here. I think this one. So if I no, it's not what I want. It's not the one I wanted. Hang on just a second here. Maybe this is the one I need. No. Oh, here. I was looking at speech to text. I need text to speech. When I present, I'm in a completely different resolution. So here are all the different voices. So I could go down here and I can let me see here, try it out, and hello, Cleveland Global, and let's try to spell it right. Global AI, whatever. Global AI boot camp, and then play.
Hello, Cleveland Global AI Bootcamp.
And then and some of these have different styles. So like if I, let me see, where's the one that has different styles? Let's see here. Oh, come on. Well, here, we'll use Andrew. But he has different styles. So he could say that, where's Jenny? She's the one I always use. They moved Jenny. There's Jenny. Yeah, she's got a lot of styles. So, for example, I could have the normal one.
Hello, Cleveland Global AI Bootcamp.
And then, it could sound like angry.
Hello, Cleveland Global AI Bootcamp.
And you can tweak these, or she could be sad.
Hello, Cleveland Global AI Bootcamp.
So some of the you can have fun going through those. There also is a free edition or a free quota for the speech service as well. But this is the one I want to show you down here, the avatars. So you have your selection of a number of different avatars, And you can tell it, hey, this is what I want you to, let me see here. I thought I had one, I created one earlier, I thought. Oh dear. I know I created one earlier. Well, okay. I think I got time. So if and let's say that I want to, not hello, but hello Global AI Bootcamp. Actually, just a second. Let me pull out, spoiler alert, this is going to be some of the next demo here. But let's say that I want to insert a gesture. I want to insert what we want to insert. Good. Okay, we'll insert this gesture here at this point. Then, if I generate the video, I think this will only take a few seconds. Oh, I know what I did. Okay, earlier. This should only take a few seconds. Only take a few seconds. Now Azure's going to make me a liar. Well, I may have to come back to this. Here we go. So now let's see what happens.
All right, thanks everyone for joining. Let's keep this quick. The goal today is to check in on the project timeline, discuss any blockers, and align on next steps. Let's start with development. Jamie, where are we on the latest feature updates?
So, and then you can also, here's the SSML mode, which I can't use right now because I've already generated this, but and that's why I was talking about, we could put unique pronunciations or pauses or something in there. But like I said, there's all kinds of stuff that you can do with this. But let's take a look at a demo that uses some code. So I have over here in an Azure Blob Storage account, I have an audio file. And by the way, this has to, for this demo, the files have to be monaural. You can't use stereo recordings for this. But I also have this, and like I told Sam earlier, I'm going to package all this stuff up. It's spread out across a couple different repositories right now, but I'll package it all up into one and send him the link over the weekend. But I have this transcript. This transcript was generated by ChatGPT, and it's a short meeting between 4 people. And then I actually used the Speech Studio to generate an audio transcription of this using 4 different neural voices. So let's listen to a few seconds of this.
All right. Thanks everyone for joining. Let's keep this quick. The goal today is to check in on the project timeline, discuss any blockers, and align on next steps. Let's start with development. Jamie, where are we on the latest feature updates?
So far, things are on track. The authentication flow is done, and we're wrapping up the API integration. We hit a small issue with the OAuth provider yesterday, but I found a workaround, and we should be good by tomorrow.
That's great to hear. Any risks that might cause delays?
Not at the moment. If testing goes smoothly, we should be able to move forward as planned.
Sounds good. Taylor, how's the UI for this looking?
The UI updates are about 90% done.
Okay, so that goes on for a few more seconds, but you get the idea. So what I want to do is I want to use speaker diarization to give me a transcript that basically looks like this. But of course, in the real world, you wouldn't have this to begin with. So what I'm going to do is I've got Visual Studio Code over here, and I made changes. Okay, fine. Hope I didn't mess it up. All right. And this is actually one of the services that you can, or one of the features of the speech service that there is not an SDK for. So this one you have to call the REST API, and I'm using a Python package called requests. Now this right here, and of course you can also do, what I'm talking about here, you can do in C# and JavaScript and everything as well, using other libraries. Or really any language, again, that supports HTTP requests. What I'm doing is I'm storing things like my key and my blob URL, things that I want to keep private that I would normally say in an environment variable, or if I'm in, again, Azure, probably use Key Vault. I'm storing them in this .env file over here, and then using this package called load.env to load them as environment variables. So I've got my headers here. This is how you authenticate using that key, and then you need the content type of JSON. And this is how you configure the request, this body right here. So first of all, content URLs, that's going to be the URL, I've got that. Now, if you're in a production application, you have it locked down. I just set anonymous read access for that entire container, so I can get the URL from anywhere. But that's what I'm doing here. I'm passing the URL to that audio file. Display name. This is a friendly name. We'll use this later to create a folder to put the analysis in. And then here's where I configure the diarization. So I tell it I want diarization, and then also the number of speakers. In this case, since I know I have 4, I set the min and max count to 4. But if you don't know, you would adjust those accordingly. So then I go all the way down here. So request.post. I'm going to make a post request to the endpoint that I got out of the portal. And then I'm also going to pass along the headers that I have for authentication. And then this is going to be the payload. You might have noticed, hey, that looks a lot like JSON. In Python, we call it a dictionary. You can translate between Python dictionaries and JSON objects very easily. But I'm going to make this post request. I'm going to get my response back. Should have a status code of 201. If it does, there's going to be JSON in the body of that with a self property. That's just going to be a URL. The last segment of that URL is going to be the ID of the transcription job that was started. So I'm doing is I'm just splitting on slashes, and then to get the last one in Python, very easy. You can do negative indexing. Starts at the end of an array, or list as we call it in Python, and then goes backwards. Then what I'm going to do is I'm say, hey, here's the job ID that I have, and I'm going to start polling this job status, because this can take a long time. Generally takes about, this one only takes about 30 to 40 seconds, but if you're doing a batch job or really long files, it could take longer. So in here, I'm just setting up a loop. This is the URL that I call to poll. So again, it's just the speech endpoint from before, tag on the ID, and I have to again have the headers for authentication. I'll get the status out of the response. There's a status property or status key, and I'm looking to see if the status is succeeded or failed. If so, I'm done. I'm not handling the failed case here, but if it's succeeded, it'll drop down to here. If not, I'm going to say, hey, I still need a few more seconds, and I'll wait for 10 seconds and show the updates. If I'm done, then I can get the display name out of the JSON, and that's going to be that friendly name that we set up here. I'm going to use that. Where am I? I'm going to use that. Now this toSnake case, this is just a little function. All it does is it takes a string and transforms it to what we Pythonists call snake case. And here's an example right here, snake case. So if you have a variable or a function or something that is multiple words, you'll lowercase it, and you'll put words, and you put underscores in between the words. So that's going to make a snake case version of the display name. I'm going to create a directory for that where we will store the transcripts. Then I'm going to actually go and get the transcripts, and then I'll reuse again that same URL. This time I'm going to tag files on the end of it. This here in Python, I'm not going to go through all of this. This is what we call a list comprehension. It's basically syntactic sugar for Lambda map. But what I'm doing is I'm getting pairs out of the response for each transaction, and I'm getting the name of the file, and then I'm getting the URL of the file for each transcript. Then I'm going through here. I'm just writing them to the local storage, and then I'm going to read each of them. I'll go through each of these files, and then I will create a training, and then I'll create a text file for each one of them that has the transcription in it. And then this one right here is where I'm going through and I'm getting each in the recognized phrases that's in the JSON. I'm getting the speaker ID, and then this in best, it may give me more than one prediction or translation or a transcription for what was said. And what I'm doing here is I want to get the first one because that'll be the best one. Okay, so now what I can do, let's see let's see this in action. So I'll say Python speech.py. Okay, so here's my job ID. It says it's transcribing, so we'll wait 10 seconds. Like I said, this generally takes about 30 or 40 seconds. So I think this is the last wait that we will have I think this is the last time we have to wait on something. There are other more elegant ways to do this, but for a demo, this will work. And a command line demo, this will work. It should be only one more.
Is the message where it states still transcribing, is that something you had in the code, or is that
Yes,
feedback
yes,
from
yes. That's something that, let's see here. Yeah, right here, right there.
Gotcha.
Yeah. Oh, it's taking more than 40 seconds. Great. I ran this twice today. There we go. Okay, just took 10 more seconds. Okay. So now you'll see that. So remember up here, we called meeting recording transcriber demo. That was our display name. So here's a folder with that in snake case. Here's the JSON that we pulled out in step 3. Let me see here where get that back. Oh, come on, give me a break. Let's see here. That was in step 3, right here where we pulled out these transcripts and saved them. This is the file here. Let me format that into using JSON. And you'll see that there's quite a bit in here that you have to parse. So first of all, it's going to give you the entire transcript, and then it's going to start to break down again those recognized phrases. And for each one, now notice there's a channel, and of course it's 0 here because there's only one channel. But it'll give you all the timestamps and everything. Here is that, but there's the speaker ID, which always starts with 1. There is no speaker 0 for this. But, and then here's that in best. They might, this is what we call a list of dictionaries in Python. It would be, an array of objects in JSON. But give me a confidence score for each one, and it'll give me what it transcribed. Okay. Then if I go over here, I parsed that, and here's where I get my transcript. So it's here's everything for speaker 1. And if we look over at the transcript, let me find the transcript here. Let's see if I can get these both in the same window at this resolution. Okay, here we go. Yeah. All right. So it starts off with Jamie, where latest feature updates. Then Jamie starts speaking. Jamie is number 2. And then after that, we're back to that's great to hear. Okay. Then back to not at this moment, which looks good. And then we're going to ask Taylor to weigh in. Asking Taylor to weigh in next. And then Taylor starts off with the UI updates are 90% done and so on. So this works. You can also do this within the speech portal. I will say one thing is that speaker diarization, that does not work on the free accounts. You have to have a paid account for that. So that, like I said, I do have another speech demo. I'm going to do it at the very end because it requires the microphone, and I've had a problem in the past when streaming. The streaming app and Python get in the fight over the microphone, and nobody wins, and the app ends up crashing. So I'll do. I've got a second microphone hooked up. We'll see if it'll work. But let me go on to the next set of demos here, which is going to be for the Vision service. So let me close this. I don't want to save that. I've done it many times. And let's take a look here. So I've got several images. So this one here, this is the one that Microsoft gives us. So let's take a look at it. Get a browser up here. No, I need a browser. Okay. So this is the image. It's somebody in front of what I think it was once called a Surface Hub. I don't know if those are still around or not, but that's the image we're going to use. So what I'm doing here is I'm using I'm using the SDK here. So I still got my endpoint and key that I'm bringing in from the .env file, and then these are the packages here for the SDK. So this is where we get into the part where I can show you, hey, it's just a single line of code. This is the boilerplate configuration like I talked about here. In this case, it's very simple. It's just creating a client and authenticating it. This is where we actually do the hard work. So we analyze from URL, passing it the URL of that image over there. And then in this case, what I want to do is I want to do object detection. So there are all these different visual features that you can pass in more than one if you wanted to. But in this case, objects. So we're looking to say, hey, what objects are you finding in this image? That gives me a result. Everything after that is simply parsing the result. So what I'm doing is I'm using the Python imaging library, which is in the pillow package, and that's what this stuff here and this stuff down here is. I'm loading up the image, and then I'm drawing for each object, I'm going to print out the object into the console so we can see the coordinates and the confidence scores and everything. But here, for each of those objects, what I'm going to do is I'm going to get the coordinates out of them, which is the bounding box. So that's going to be the rectangle that would surround the identified object. Then here, I'm going to draw a rectangle around the object on the image. Then I'm going to draw another filled rectangle below it to draw the text with the label, and then I'll save that output. So let's try this one and see how it works out. Python is going to be Vision 01. All right, if we look over here, we'll have output image, and there we go. We can see that it's identified a person and a television, and here it's showing us that the tag that it found was a person with 90% confidence and almost 81% confidence for the television. Now, of course, that's the one that Microsoft gives us. So let's take a look at one that Microsoft did not give us, just to prove that there's nothing crazy going on here. So let's take a look at this image. So here's an image of some art supplies is what it looks like. So let's comment this one, uncomment this one. I believe Jared mentioned that the hashtag is the comment in Python. And let's just run this again. Okay, this time it says that it found a cup and a person. It's pretty confident about the person, but not so confident about the cup. Now let's look. Oh, and this one at this resolution, it's gonna be hard to see at this resolution, but here we go. You can see the cup right there. And then even though it's a drawing, it still identified that one as a person. Okay. 231. Let's go ahead and look at the OCR demo real quick. Okay, so this one starts off a lot like the previous one. Again, I'm creating the same image analysis client using the same key and endpoint as before, and I'm doing the exact same call, single line of code to do all the hard work. The only thing is this time, notice the visual features read. That's going to look for text. And that means my result is going to have a read property on it. And so the text is organized into blocks, and the blocks are organized into lines and such. But at any rate, I'm going to iterate all of those, and I'm going to print out what each one of them is. Then I'm going to do something similar to what I did with the previous demo, in which I'm going to get the bounding boxes of all of each line, and I'm going to draw a rectangle around it, and then I'll spit it out down at the bottom. Okay, so let's take a look at this first image here. And we'll see that this is not your standard form. Again, this is a more generalized OCR model. So first thing that you'll notice is that we have text here at an angle. We also have many different font styles, different sizes. It's not laid out. It's not laid out in a nice table or lined up or anything. We also have right here. We have this mixed. We have mixed here, and we also have mixed fonts here. This one we have some damage to this sign. And so how's it going to handle that? So let's take a look and see what it did. Let's move this over here, and let's run vision2.py. All right. So first of all, let's take a look at what it found. Let's see if I can get the original image in here. Actually, let's go ahead and look at the output, and then we can kind of look at this two at the same time. Okay, so you can see that it did find the text of the image, text at an angle rather. It found that, but it has so ouch. Let's see here. Then there's play it safe. That's lines 2 and 3, or actually play it is line 2. It shouldn't is line 3. Safe is line 5, and so on, or 4 and so on. Also notice that it did happen that it did this one down here, the mixed font. It got that all as one. It did find that all as one line, and it did also recognize that as safety shoe store. Now this one, that should be visit the, but the S is completely obscured by the damage, so it found the it. Then for the confidence scores, you can see also that down here, when it recognized safety, it went with it, but it wasn't very sure about it. So I got all the confidence scores down here. But overall, I mean, ouch, it wasn't. That's kind of strange. Maybe it's the wavy outline of the text. But this, so that's just so that's kind of like it's more of a generalized model, but there's more that it can do. Let's see here. Let's take a look at the or different types of text. It also handwritten text. So take a look at this. Just something I scribbled out on the iPad and saved, but Azure AI Services Computer Vision is obviously handwritten. So let's take a look at that one. And there's the output. Scroll a little bit. And again, it found 2 lines, Azure AI Services, Computer Vision, and it's fairly confident about what it found, even though sometimes when I write, especially if I have an RE, very often I'll try to connect those together and other things. And then like that CE there, it still found it. It still found it. And one more, and then we can talk about some questions if anybody has any, and then if you want, I can risk the other audio demo. Well, I'll tell you what it is, and then you can decide if you want to risk it or not. I think it's pretty cool, but I'm my own worst critic. It also recognizes languages other than English. This is French. I believe that means complete plumbing. I know this means plumbing. I think that means complete. I'm not sure. I'd have to. This is from a blog post I wrote back at the beginning of the year, and so I don't remember what it says. But let's take a look at this one. Let's run this one more time. And I have to save it. And so it did find the lines and the words that it found. It's also was confident. It's not confident about the second one, but it's confident. It may be because of that dot. That dot in there is kind of messing with it. But let's do French output, and we'll see that it did indeed recognize it. Okay. All right. No questions. Okay. So let me show you, and this one also I can't do that one in WSL. I have to do this one in I have to do this one on the bare machine, on the bare metal, because the WSL can't access the microphone. So this is another speech services demo. And this one, I watch way too many police videos on YouTube. Way too many. In fact, if a notification were to come up, hey, live police chase in Los Angeles, I'd probably say, okay, thanks for joining, everybody. Not really, but I'd be tempted. But at any rate, and many times, you're watching them, they're in a chase, and they'll call in the license plate, and they'll use the NATO phonetic alphabet, Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, and so on, instead of saying the letters. So this became sort of a learned behavior with me, and I'm driving down the street one day, and I'm seeing the license plate, and I'm transcribing the NATO phonetic alphabet of what I see on the license plates. And some of them, I remember one of them that was really bugging me that I never could remember. I never could remember November for some reason. And I think whiskey was another one. And what was the other one? I think India or something. But at any rate, and so it was really bugging me. And I thought, hey, this actually has a great demo. So I created a NATO phonetic alphabet trainer. And so what will happen is it will generate right here three random, in this case 3, but you can configure it to any length, but however, a collection of random letters. It will read out the letters to you. So I'm going to be using speech synthesis here. And then it will wait for you to transcribe that, speak that back using the NATO phonetic alphabet, and then it will tell you whether you're correct or not. If you're correct, it just says correct, and if you're not right, it says, hey, here's what I expected, but here's what I heard you tell me. So again, this time the boilerplate configuration is a little bit more complex. We have to create an instance of speech synthesis, an instance of speech recognition. We have to select our voice and such, and then we have to tell it which audio output we're using. So which microphone we're using, and such. And then down here for each one, here is the single line of code that does the hard work for speech synthesis, so text to speech. And then here is the one line of code here that does all of the hard work for speech recognition or speech to text. And then down here, this is just, again, analyzing the results, which again is what is most of it. So if you want, I will attempt this, but so let me go ahead and say that if this does not work and it does crash, thanks everybody for joining. I'll try to come back as quickly as I can, but if I can't, thanks for joining. Does anybody have any questions before I try this real quick?
Yeah, I have a question for you, Doug.
Sure.
The dialogization where you set person 1 to say XYZ and person 2 to say ABC, can you actually coordinate that with the graphical representation in a video where you have 2 individual characters talking according to that dialogue?
So that does not work. So that does not work in. So what you want to do is you want to do that in real time. In other words.
Not so much real time. I mean, I can like prep it in advance, but I just want to know, can I dialogue the audio as well as the video, meaning have 2 separate individuals on a video?
Oh yeah, yeah, because it's because the audio is what it's going to pay attention to.
But as far as like the lip syncing of the characters.
Oh, okay. Yes, you could. In theory, you could, because it gives you because that JSON in there, that big glob of JSON and the recognized phrases, it gives you the timestamps.
Okay. So who says what and when?
Yes. So
okay.
So let me see here. Did I kill that? No. Let me see here. Hang on. Let me go back to it real quick.
So you got to do some serious JSON editing then.
Oh yeah. This is the. Well, and also remember, and there's no SDK for this. So, yeah, so for each of these recognized phrases, what you're going to do is see there's an offset and a duration, and it also has it in ticks and milliseconds, so it has it in several different formats. But here's your speaker, and here's the normalized version of what was said. So I think all the information is there to do what you want, but you'd have to do some serious JSON parsing for it. Yes.
Okay. Thank you.
All right. No problem. Anything else?
Any other questions or comments for Doug?
I'm hoping that worst case scenario, let me make sure real quick that I've got the correct microphone selected, because otherwise I know it will crash. Okay, so
if we do get disconnected, I got some wrap-up slides to go through, so it'll give you a few minutes to reconnect and rejoin.
Okay, great. Well, let's see if this sucker works here. Hopefully, so Python speech.py.
Say the following letters using the NATO phonetic alphabet: L, S, P.
Lima, Sam, Pocket.
Correct.
No, that's not true. That shouldn't happen. That shouldn't have happened. Also, I will say this microphone is terrible. So let's try it again.
Say the following letters using the NATO phonetic alphabet: R, B, D.
Romeo, Baker, Delta.
Correct.
Okay, that one was correct. Now let's do one that's incorrect.
Say the following letters using the NATO phonetic alphabet: A, F, C.
Alpha, Baker, Charlie.
Incorrect. I expected Alpha. Foxtrot. Charlie but heard Alpha. Bravo. Charlie.
So the reason why it's saying Bravo when I said Baker is because it's only taking the first letter. Actually, that's another limitation. But again, it gives you an idea here of what's going on. And also, this is a historic occasion because that is the first time that demo has worked online. So, but at any rate, let me go back here real quick, and there's my link tree one more time, if you so wanted. And again, thanks Sam for having me, and thanks for putting on this event, and thanks to everybody for sticking around.
And thank you for joining, Doug.